Okay, in this video, I'm going to attempt to talk through these Fleming's left-hand rule arrows that were on the page you did on the motor effect. To do this, what I've done is in the 3D drawing tool on the surface, I've drawn in these three arrows that hopefully are rotatable, and that we're going to be able to set up to these three different things. So I can start to move these around. Now, at the moment, they're set up to match this hand underneath. So what they're trying to replicate is Fleming's left-hand rule. So probably what's sensible to at this point is set your hand up like this hand at the bottom. You can see for this hand, there is a pair of magnets, north, south. The little red squiggly lines in this diagram are meant to represent the magnetic field, and the first finger is pointing from north to south in the same direction as the magnetic field. Up here on my top diagram, my arrow, my blue arrow, which is always going to represent magnetic field, is pointing in the same direction, approximately. There we are, maybe a bit more like that. Same direction, approximately. The current in this diagram is running in this direction through the wire. That's sort of from the back towards the front. The second finger you can see is pointing in that same direction. And on my rotatable diagram up here at the top, current is running from the back towards the front. And when I put these two together, as you hold your left hand like this, your thumb points upwards. The thumb shows the direction of the force on the wire. And again, in my system at the top, the red arrow for force is pointing upwards. So I'm going to get rid of this diagram because the more space I've got for this 3D one, the better when we're going through these. So over here on the left is the set of 8 questions I gave you about Fleming's left-hand rule. The first one was an example, but let's just show that we can get this set up. So I want my set of arrows here to have the pointing up and the current going left to right. So with a bit of manipulating with the mouse, there we are. We can't see the words anymore, which I know is annoying, but maybe if let's make a quick note of them down here. Let's say red is always, let's write it down here so we don't forget the force. That's on this diagram over here. Blue is always the field, and green is always the current. So as most of the time we'll be able to see those words, but we can't at the moment. So in my first setup, that's this one, the one that was done as an example, you can see hopefully that this is the only way of setting up Fleming's left-hand rule. If you want to do this in front of you now, take your left hand, point your thumb up, point with your first finger, and then have your second finger sort of coming across at 90 degrees to your first finger. We should be holding our hand so that our first finger is pointing towards the top of the surface. That's for field. Our second finger is pointing towards the right-hand side of the surface. That's for the current, and the thumb is pointing sort of straight at yourself. So in each case, we're going to manipulate those around. Now, I looked for a 3D hand that was rotatable, and I couldn't find anywhere. And so this was sort of the next best option, I think, on rotating these. So for the second diagram, you can see that we've got a current going upwards and a field going left to right. So where I had this previously, my two arrows are appear initially to be in the right direction, but they're the wrong way around because blue is field and green is current. I want current up and field the other way. So if I rotate this all the way around, and then where are we? So what am I trying to do? Blue up and no. Blue across, green up. There we are. Got there in the end. So green going straight up for current, blue going left to right for field, and you can see the forces away from us. So let's add that in on here. Let's choose a sort of color that we don't normally use so that we can clearly see they're the answers. Let's go with the sort of pinky color. There we are. That's fine. So we're going to show a cross on the back. That means an arrow pointing away from us, remember. Right, let's go through and see if we can quickly set up the other ones. So we want force, red arrow coming towards us, field, blue arrow going to the right. So if I drag this round, force coming towards us, field going to the right, means that the current has to be going straight down. I'm going to label it as I to speed things up slightly. Next one, field coming straight towards us. Field is the blue one. Force going down. So Again, this is a bit peculiar to rotate at this point. I think I have to go all the way. No, don't go that way. No, I can't go that way. Maybe I can't. It's peculiar. If I twist it all the way around there we are. Then we're heading in the right direction, aren't we? Now I need to. Can I flip it over that way? No. Can I flip it over that way? No. The 3D model has a limit on how much it can go, doesn't it? So I want field coming towards. Okay, I can't set it up like that, so I'm going to set up the reverse of it. So I've got field coming towards me and force going up. Now in my diagram over here, I want field coming towards me and force going down. So what we have to imagine is this is rotated by 90 degrees. You could turn your surface upside down, I suppose, and it would work, wouldn't it? But so on my 3D model, current is going to the left. So once I've rotated it 90 degrees, I want my current going to the right on this one. There we are. There is a limit on this program, obviously. Next one, force, red arrow coming straight towards us, current going straight down. Let's see what we can do. It's that way, isn't it? There we are. So red arrow coming straight towards us, current, green arrow going straight down, gives us field going to the right. And again, remember, you should be able to set all these up with your hand as well. So if we're going back to this, what does this one look like with your hand? Well, your second finger should be pointing towards the bottom of the screen, the bottom of the surface, pointing downwards. Your thumb should be pointing, sorry, I've done it the wrong way. The thumb should be pointing away from you. Now let's rub that out and correct. I'm glad we stopped on that one for a second. Thumb should be pointing away from you. There we are. Force away, current down. There we are. Keep twisting around. We'll get there in the end. There we are. Force away from us, current down means field should be to the left. Maybe we should just go back and check those other two that I've just done since I've just got one wrong. Let's just double check. So for that one, force was towards us. I think it's because this is the first one I've done with an arrow away, but let's check. With force towards us and field to the right, yes, we get current down. Next one, field towards us. This was the one that we couldn't actually set up, wasn't it? And force down. So we have to picture this rotated by 180 degrees. Sorry, I said 90 degrees earlier. Rotated by 180 degrees would give us current to the left. So I don't think I've got any wrong. It's that switch to arrows going away I need to watch out for. So the next one, current is going away from us, field is going to the right. So that means green arrow pointing away from us. There we are, like that. Field going to the right. So I want to flip this. This is the control that sort of my computer gets confused by. So if I do that, no. I think we've got to the same problem where there's a limit on what I can do in that direction. Let's go for a reverse one again. So I'm going to have the current going away from me. I want the field going to the right, but I'm stuck with the field going to the left. So I need to imagine this rotated by 180 degrees. As I bring that blue arrow around 180 degrees, then of course I bring the red arrow around 180 degrees as well. So the force is down. And last one, is it the last one? No, two more to go. Next one, force towards us, current up. I think that's a quick switch. So force, red arrow coming straight towards us, current going upwards gives us the field to the left. And last one, we want the force coming straight towards us. And then the other two arrows aren't labeled, which is a bit peculiar when you first encounter it. But from here, force away from us, don't we? With the force away from us, there we are. The only way I can have one arrow up and one arrow right is if I've got them the right way round. And that is with the current going up and the magnetic field going to the right, as is in my diagram at the moment. So again, last one, let's set it up. This is one of those ones that's awkward to set up with your hand. You want to set up so that your thumb is pointing into your surface screen. So on your left hand, have your thumb pointing straight towards the surface screen where that little cross is that says force. Then you want your first finger, your pointing finger, pointing towards the right side of the screen, and you should find that your second finger then has to be pointing straight upwards. If you've got your Surface flat on the desk, that's almost impossible to do. If you've got it standing vertically, then it's not too an uncomfortable position. So sort of lay the back of your left hand on the desk in front of you, thumb pointing away from you, first finger to the right and second finger pointing straight up.